Hey, everybody. Just give people a few more minutes to join. And while we wait, remember to put your name down as an attendee in the Google Doc. Okay, let's go ahead and get started. Um, we do have a couple items on the agenda, items on the agenda today, including a presentation from Amari, I see right here. So, and the other one is a pull request from Usama. Usama requested 5 minutes to go over this, and so we go ahead and start with that. Usama, are you here? Yeah.
Yeah, hi Jim. Yes, I'm here. Should I start?
Yeah, go ahead.
Okay, thanks. Yeah, we had a discussion about the project several times. We discussed among the authors. We are fine to move it to the repo that Dan suggested. Although we have strong disagreements, one of my co-authors is on summer vacations. We will send an email formally for that. We kind of disagree with the declaring the project as complete by the POC proponents while we were doing the formal part. They cannot speak on behalf of me. Anyway, I'm going to just show you what we have for the PR, and we would like to close this matter here specifically. What Dan suggested, or what I understand Dan suggesting, was that we have put these artifacts in the CCC attestation TLS proof of concept. And we have that here, which is clearly highlighting it's a high severity, do not use. Also in the README that I will show you, giving an overview of the 7 types of binders that we considered. and then giving a proof of insecurity, different binding levels, correlation goals. The main result is trimmed down to specific one, which is related for this specific proof of concept under the, let's say, the small scope, which Dan suggests. Under that scope, we have the results for that specific one, and recommendations for the designers not to use it. And then the trivial things as we had before, like the author's papers and the technical report for people how to see what was done here. For instance, like to build on top of that or move solutions around, because I mean, one of the things that we contest is saying that it is, I don't know what word Dan used. So there was something like it is, um, the draft is whatever it was. So that's not the case. So the other two proposals are actually using that as a base. So it can be, and we are very much actually using the same in the next base. And thanks to all of you um, who have contributed, specifically Tiadin and who else I see, Marcus helped a lot. Um, uh, okay, and then yeah, so how to run it. So that's what it is saying. If you want to model it and run it, just use it as it is. All the typical instructions, how it is organized, and then all the instructions, different ways like to get the attack traces, saving the logs. There are horn clauses, if someone is familiar with that, to go deeper into how ProVerif internally works, the mathematics behind that, and some of the talks, if someone wants to have a look at what was presented specifically at the 4 CCC meetings, and Jens very kindly presented it also at the CCC summit, and we will add this poster and video link afterwards. And yeah, the comments. So that's pretty much it, what I wanted to say. I want to very quickly, in just 1 minute, maybe also show the concern that Nathaniel had. He has a concern about this specific statement, and he proposes a different statement, which is much broader than what the scope of the, or let's say the limited scope of what Dan proposed is. Like, it's taking into consideration pre-intra post. The artifacts are only about intra. We cannot make this statement. So what we did is that, as he proposed, we removed this statement and it changes nothing basically. And it's my reading that he's fine with it. I would like to clarify, one of our authors has not seen that. He's on vacations, as I said. So we might make a little bit of small changes, but that's pretty much it. There is nothing controversial, so to say, as we have discussed in 4 meetings. So if you have any comments, we will be happy to address any comments or thoughts on this.
Yeah, thanks, Osama. Yeah, I think this probably requires some more offline review. So anybody in the community here that's interested in reviewing, the chairs will review this, and maybe we can continue this discussion offline, unless anybody has
Sure. Sure.
immediate
The
concerns.
only thing of showing this was that Dan wanted it to be completed by the end of the week, and we would like,
Okay.
let's say, within 1 or 2 days, so that we have some time for discussion. As I said, it's summertime, and like we have to fetch our co-author somehow. And it would be nice if people could, like, let's say, in 1 or 2 days, submit all the feedback that they want or any comments on this, so that we can wrap it up until the end of the week. Thanks.
Yep. Thank you.
Thanks for reacting so quickly to that, Osama.
Thanks,
Okay.
Dan.
Yep. Thanks. Our next presenter here, Amari, is going to talk about attested DNS. So, Amari, if you're ready to present, introduce yourself and go ahead and start sharing.
So one quick thing before he starts. So Dan, we would need that KBS repo to be up until the end of the week, because it's referred in so many places. We have to manually figure out where all the places it is and then correct that. So that would need some time. The other one, I mean. So thanks for your patience.
Yep, through the end of the week sounds fine.
Hi, everybody. My name is Amri. I work at Microsoft in Azure Research, Security, and Privacy. I work on a range of projects, and today I'll be talking about Attested DNS, which is a paper we presented at Using Security about a year ago, and for which we've run various POCs. So we'll talk a little bit about a couple of prototypes we've built to demonstrate how this can work. So first of all, I guess everybody here is pretty familiar with this, but for background, confidential services today are upgrading to confidential computing, and what that means is that they're running increasingly in TEs, and they use those to protect their code, their data from the rest of the cloud, from the hosts they're running on, and they use remote attestations to communicate, what platform they're running on and what code they're running. And so relying parties now have this ability and also sometimes burden to authenticate and authorize the services they're talking to based on these remote attestations. There's various ways to do this, but a lot of them are variants of what's described here on the right. You generate fresh key pair per T, you attest that key pair, and then you use that key pair going forward to do things like TLS or signatures or various other things like that. So I guess this is fairly uncontroversial and well understood. But just to get this out of the way. So today, the way we do all of these things is we do attestation after TLS handshake. Again, this is not always true, I guess, but I think it's largely true at Microsoft. And so the benefit is that you don't have to modify your transport stack. So you can use your standard transport, your standard TLS, but you end up with ad hoc clients because the clients have to do extra work after they've done this initial connection establishment. You have to, there's a bit of risk if there's a delay, and also you end up with some extra round trips. You end up having to maybe talk to other components or other services to establish things. You can do attestation during TLS handshakes. You have to modify the handshake. You have to embed attestations, maybe in existing credentials. Today, I think it's probably fair to say that there isn't really a full, widespread standard for this, and so you end up with ad hoc clients and servers, and your interop is sort of limited, by how widely your variant of attested TLS is implemented and widespread. And so I think what we're trying to do with attested DNS is we want to attest before TLS. So we would like to have the attestation done ahead of time. We want to resolve these things ahead of time on a different cycle. And by the time you connect to a service, you as a client don't have to worry about this, and you don't have to do changes on the client side, or too many changes on the client side, because as we'll see, we still have to make some tweaks. So that's kind of where we're trying to go there. So in a nutshell, to try and capture the high level ideas, we're mapping services to domain names. So we're saying you have domains, subdomains, or you have names for services, and you want to figure out which T's you can trust for a given name. So for that, we create and we publish service definitions, which you can think of as predicates. And they're predicates that you can evaluate against attestation reports. And they tell you if an attestation report tells you that a T is a sort of valid instance of a service. Is it running the right platform, the right code for that service, that type of thing. I'm simplifying here a little bit, but that's loosely the idea. Then you want to have an authoritative DNS server that itself runs in a TE, and its job is to securely enforce these definitions when new TEs want to join a service. So if a TE wants to register and it says I want to become an instance, I want to serve traffic for this service, a service by this name, then it needs to talk to this authoritative DNS server first, and that will check the definition against the attestation, and we'll say okay, I'll give you this name essentially, or you can be registered under that name, for some lease or for some period. And then we want to leverage as much as possible existing DNS standards infrastructure. So the existing resolvers, these are obviously very nice because they let you distribute and cache, obviously the addresses, but also your TLS keys, so that they're easy to find for clients when they want to connect to confidential services. And as a bonus, we would like to have sort of like full history of how this authoritative DNS server behaves, because obviously it plays quite an important role in this architecture. And so if it misbehaves or it ends up doing bad things, we will want to understand, what the impact was and how this came to happen and all of that. So that's the big idea behind attested DNS. So the paper was published at Usenix last summer. You should be able to find it online quite easily. And so it defines various protocols for registration, zone delegation. There's also an extension for certificate issuance, saying like if you have clients that maybe don't have the ability to do things like Dane, one of the ways you can try and retrofit these concepts for them is to use X509 certificates. And so the idea is that you can improve security for all clients. So your enlightened clients, the clients that have the right bits for DNSSEC and Dane, they can get extra security, and if they have the ability to verify attestations on top, they can maybe check things directly. But even if they don't have that, they benefit from the fact that they're using an auditable system that at least some clients or some auditors are able to check. So it's sort of like the same kind of benefits you get from CT logs, even if you yourself are not witnessing the logs or verifying them. The fact that enough people are doing that does give you a degree of sort of, not quite herd immunity, but something like that. And so this paper and this idea is part of a logical progression. So we did some earlier work on what we called "Why should I trust your platform?" So this is confidential containers, building a sort of policy engine you could run inside confidential containers to have a nice serviceable but still precise keys running in containers. Then work on code transparency. So there's a system called Microsoft Signing Transparency now, which is an implementation of an IETF standard along those lines. And why should I trust your service is sort of the next step in there. So once I believe that your platform is sound and is secure and is isolated, once I believe that your code is transparent and auditable, and I understand what it does. I guess the next question is the service endpoints that you're exposing to me. Do I believe I have a full understanding of that, or is it a black box to me, right? So the first implementation, which is what's described in the paper, is a research prototype done in SGX, and it's a slightly older platform and set of systems. And the client existed in the form of a web browser extension. The important idea that this allowed to validate was that you did not pay any latency overhead for doing things like this, because essentially you could verify attestations in parallel with the TLS session establishment, even if you were an enlightened client and you cared about verifying attestations yourself. And obviously, if you didn't and you just used Dane, then there was no overhead. You just got your TLS keys from DNS, and you're able to establish the session directly. Sorry, something popped over, so I guess there are some questions. Let me see if I can display it on the right screen. Tested BGP next. Yes. One thing at a time.
So in this diagram, where's the verifier running? Because the evidence comes from the
verifier. So here you have the ADNS client at the bottom. In this case, if it's an enlightened client as defined in the paper, it's getting the attestation over DNS, and so the verifier is running in the ADNS client. I'm not 100% sure if does that show on everybody's screen?
Yep.
Yeah.
It shows.
Okay.
Are there actually two verifiers? Is there?
Yeah.
Okay.
So for most, so we're going to talk about the sort of second implementation of this, but the first stage of verification is absolutely done here. Oh, sorry, I'm drawing over the wrong box now. Yeah, no, that's right. That's the sorry, I'm a bit confused here. No, these are, so the web server T and the database T, they're the services that talk to each other over an HTLS mutual TLS, sorry, and then the client connects to the web server over TLS using Dane here. I think that in this diagram, actually, the tested DNS server is not shown, and so that's the first thing that verifies the attestations before distributing the records. And you can also have an enlightened client that verifies the attestation itself. Maybe we'll just move on a bit, and then I think the second implementation is a bit clearer and it's a bit easier to explain. Yeah, so there are some performance numbers. Essentially, the drawing stays on the screen. That's unfortunate. Okay. So I'm not really used to Zoom. Okay, so the second implementation, that's something we've done with confessional containers. That's a bit more modern. And essentially, the big ideas were to formalize the transparent service and platform definitions. So to have them be separate things in a policy language, have them be transparent separately, and then they come to the system with inclusion and consistency properties. And then we wanted to support standard clients using OpenSSL. So rather than doing enlightened clients and custom web browser plugins and essentially having to deploy a lot of machinery on the client side, which is not very appealing, and it's kind of the same level of intrusion that you have to have with remote attested TLS. The idea was to try and see if we could do something that was a lot more generic and would support a lot more clients at once. So the big thing here, which I'll show in a moment in a demo, is to patch OpenSSL to essentially have it reach out, get the keys from DNS, like from the TLSA records, and then configure Dane to make sure that those keys are used to do the handshake. And so that means that if you have code that uses OpenSSL, you don't have to modify your code. If you're just willing to use this patched OpenSSL, then you get essentially your trust delegation to the attested DNS server without having to do anything separate. So it's a lot more modular, and it's something that you can deploy without having to patch the clients. Yeah, I think the other thing was to show the footprint could be a lot smaller than the previous versions, because we're trying to do fewer things, and that you could do client-side trust bootstrap more easily. I misspelled bootstrap. So a question you might ask is why do you trust a DNS? So if you're connecting to an attested DNS resolver, like, why do you believe that it's correct? How do you know that it's not just serving you junk? And so obviously you have a bootstrap phase where you need to go and check the attestation of that early on and cache essentially like the KSK from there and say from here on, I'm willing to talk to that. I'm willing to resolve from there, but I know that this isn't just serving me junk. So we've made a small version of this, which is easy to deploy and to include in sort of VM images and so on, which I think is a progress over what the previous version was doing. So the basic idea, what the demo covers, is we have our clients as trying to establish that the DNS server that it's talking to is trustworthy, and that the registrations that were performed by various services on this server in the past are correct and were done honestly. And once this is established, it can use it to resolve services or service names and get TLS keys that go with them, and then it can perform handshakes directly with the services without having to check the attestation for each and every service, and without having to know what the platform policy or service policy, the platform definitions and service definitions are for these services. So we're going to go through a few steps. The first thing is we're an operator. We're setting up an DNS server. Then we're setting up a platform definition. So it's kind of something that tells us all the services that we're going to run in this zone. They should all be running this hardware with this level of patch, maybe this configuration exactly, or something newer than that. And then as a service owner, so this is for each individual service, we can set service definitions. So we can say, for something to be a valid instance of my service, you need to be running this code, or you need to be your container needs to be captured by this, execution policy or something along those lines. Yeah, and then as a service instance, so when you come up, you register. This is automated with ADNS. Obviously, you hand over your IP and TLS key. There's some details there. You can do more than this. Obviously, you can have multiple keys, and there can be multiple ways you can be reached. But the simplified version is that. So when you're a client, then you want to connect to this resolver, and you want to make sure that to this server, and you want to make sure that it's a correct ADNS. So you need to bootstrap trust in there. You need to do an attestation verification on your side, and then you can start to discover things from there, and you can establish your sessions. So this bootstrap bit at the beginning is a bit non-trivial. But it's something that you can package, and then once you've done that, then all your future connection establishments a lot more straightforward and don't require code changes to your clients.
Hey, Amar, we have a couple of hands up. It's a good time.
Sorry. Gary, sorry.
Sure. Sorry to be specific on the S&P implementation, but a couple of questions. Where's the attestation being generated? Is it the S&P guest report, or is it being generated within the CVM, the S&P guest? Second question is, how are you deriving the key to sign the DNSSEC records, or even using DNSSEC? Okay.
Yeah. So to your first question, it's the S&P guest attestation. So this is all run with confidential containers. Inside the CVM, essentially, you create a guest attestation, and that's the attestation you provide when you register your service, so that captures your measurement, the host data in those schemes, captures an execution policy that binds the layers of the container you're running and the command line entry point, and everything you've mounted and all that kind of stuff. So you end up with a guest attestation.
Okay, so the DNS client is taking care of freshness then, and it's providing a nonce that can be used in the guest report data, correct?
Yeah, exactly, and it has to be done at a regular interval. Otherwise, obviously, you get sort of, well, you can't renew essentially your entry in a record, right?
Okay,
Yeah.
okay, and what key are you using to sign the DNSSEC records? Are you even using DNSSEC?
So the DNS server itself runs in a TE, and that creates an ephemeral key. Well, it's not that ephemeral; it's long-lived actually, but it's created inside the TE, never leaves the TE. It's sealed, in case you need to restart it. But that's how the KSK is created.
Okay.
Yeah.
Okay. Fantastic. All right. Just a comment on the DNS client. If it's caching records, does it need to, or sorry, just another question. Does it need to be updated? Do the records need to be updated if the TCB changes for the S&P guest, like in the case of an impactless update? Or does it, or is the record itself kind of trusted to, entrusted even through firmware updates on the S&P guest that affect the S&P guest?
No, that's a really good question. The answer is we lean on the TTL, and so the idea is that if you think you want to handle those and to cap sort of the amount of time that you'll be running before the next platform definition check, then you'll set like a pretty short TTL, and then the client will need to refresh the records fairly recently. And then the way the client discovers that something is no longer trusted is because they drop out of TTL. So there's not a specific revocation mechanism. Instead, if you think you want to have like sort of reasonably quick revocation, you set short TTLs, and your clients have to refresh the records fairly regularly. That's just kind of how it works.
Okay, thanks.
Yeah. Mohammed, you have your hand up.
Yeah, hello. I had actually a question a few slides back when you were showing the overall architecture. So I am actually trying to see at what point so you had a lot of blocks. If you go back to that slide, sorry for that.
Sure, no worries. Hang on, sorry, I'm just juggling a few windows. Not really.
Sure.
This one?
No, one before, where you had all the block diagram of all the architecture, kind of DNS and all. Sorry, I've been
Yeah, that
reading
one.
and for a while. Yeah, this one, exactly.
Yeah.
So I'm trying to understand the overall scenario, and what I find missing here is the time, and that's what my question is related to. That the I see a lot of like things are interacting,
Yeah.
but I would like to understand, number one, you talked about something called as bootstrapping or something like that.
Yeah.
And number two, if I understand correctly, the design that you have in there, the web server TEE will get attestation before that TLS connection with the database TEE will happen. Is this correct? So I'm trying to distinguish between pre, intra, and post. So you are kind of doing the pre-handshake attestation here. Is this correct?
Yeah, I don't want to spend too much time on this diagram. There's a lengthy explanation in the paper about how this, how this goes. It's not quite what the second design that I'm showing does, which is simplified. And so I would rather, show the bootstrap and so on, like in the later slides, if that's okay. I think that will make a lot more sense than,
Sure,
going into the details of this diagram.
just the
yeah.
just the crux of my question is it
Cool.
pre, intra, or post? So maybe you can just tell me whether
Yeah,
it's
yeah.
pre,
So
intra, or
the
post.
attestation,
Thanks.
the idea, right? The overall idea. And here this is like a bit muddled because it's showing these enlightened clients that can also get the attestation through DNS. The idea is like not to do that. The idea is that the DNS server will do the attestation verification when the service registers with it. And the client never deals with attestation other than the one time when it initially establishes trust into the DNS server. So as a client, you start up, you bootstrap your trust in the DNS server by checking its attestation. And you're like, from here on, I believe what they tell me because I know they're good for it. And I know they're running a correct DNS server that's auditable and so on. But you as a client never check the attestation of all the services you talk to. Instead, the ADNS server is doing this and it's taking care of that for you. And it's distributing and it's providing to you through the standard DNS mechanism up-to-date records that indicate where you can talk to these services and what TLS keys are currently valid for them. But the attestation is not something that you need to worry about. You just need to attest the DNS server. Does that make sense?
Kind of. I will state it in one sentence, which is to say that the DNS server, from a time perspective, DNS server is verifying the evidence beforehand. And it's kind of pre-handshake in a special sense, that it's not the client doing that verification. So it's the ADNS server which is actually doing that.
Yeah.
Okay, perfect. Thanks.
Yeah, that's right. Yeah. Okay, Thomas?
Yeah, I'm Mauri. Just a quick question about naming. Who picks the domain name for the node? And so basically, I want to understand how the name that is used by the attested node is made known to the potential clients.
Yes.
Whether that is even required, because maybe nodes are identified by the service they offer, for example, via SRV, RRs, or something like that, and therefore there's no need. They can be anonymous somehow. But
they could be. That's a good point. In the paper and in the prototypes we've done, we always use the name, and essentially the idea is we just use the standard DNS delegation model. So at every level, you have a policy, and the policy decides how the names are attributed. And so essentially, if you meet the authorization criteria, you can register a name under under there, right? You can register something in that zone, and that could be the name of your service. So to take a very simplified example, let's say you have whoever operates this at the scale of a company, they've created zones for different regions, and when you spin up your service in that region, you go to the zone for that region, and then the policy maybe authenticates you and authorizes you because you've got like the right identity to create a subzone for your service under that region, and then you can name that. And then what you distribute, what you make public, what you talk about with clients and people using your service is the name of your service. So it'll be, your company.region.service. Node or something along those lines.
okay.
The idea is to lean on the names quite heavily for service discovery.
Makes sense. Thank you.
But there are other ways to do it. You're right. That's not the only way to do it.
Yeah, absolutely. That was what I was trying to understand. What kind of things have you explored in the space?
Yeah, the honest answer is we've not explored anything further than that. This is like a pretty simple scheme, obviously, to do this. And I'm not claiming that it's the best or anything like that. That's just something that's natural. It's something that's quite widespread where we are, and so sticking with it seemed natural. But yeah, there are other options. You're quite right.
Makes sense. Thanks.
Okay, cool. So now we're just gonna go and set up or pretend we're setting up an ADNS server. So we're gonna start up this ADNS, a CCF application. That's just a framework for putting together distributed applications. It's got what is called a constitution. It's just a bunch of roles. It's a configuration for deciding how changes happen going forward. So who's how they're called members in that system, how members are authenticated and authorized to make changes to the application going forward. And there's a set of member identities who are allowed to govern the system and decide how it evolves over time. Then we configure a technical configuration. So we're just going to give it an address where the DNS server is running. We're going to give it an initial zone here just to make things simple. And we can run this in a set of confessional containers. Ideally, we run like a distributed setup so that we have resiliency and we can tolerate failures, of course. So the initial things we need to set up is a platform definition authorization policy and a service definition authorization policy. So to your earlier question, Thomas, these are the things that decide who is allowed to register services. And here for a single zone, we're just going to say like, how do we authenticate and authorize clients who want to register TEs in that zone, right? So here we have, so we use Cozy Sign 1 envelopes. I guess these will be familiar to a lot of people here. And we use CWT claims that are in there, and we have sort of like issuers that we believe we accept when people are sending us platform policies, and the same thing for the service definitions, right? And so we need to configure an initial platform policy. So here, this is quite simplified, but we're saying maybe our platform, the platform that we accept services running on in this zone, they need to be, running AMD, and they need to be like one of these two architectures. The TCBs need to be at least this high. We're happy with things if they come to us in that shape. So UVM is the utility VM that's running these confessional containers. So the base VMs have to be, endorsed by this issuer, and maybe we'd have like a cap on they need to be at least this new. This is not here in this particular definition, but I think it's at the bottom of the screen. It's got cut off. But that's the basic idea. So we need those settings, and then with that we can create our initial ADNS server and start it up, right? Yeah, it prints a bunch of lines that tells us it's definitely running and doing the thing we said it would do. So then we configure the platform definition. So we need to send that information to it, and the platform definition authorization and the service definition authorization. So we need to say who is allowed to talk to us and define services, and also what the baseline for the platform should be. So again, we run some commands and we send some proposals. They're registered in the server. They're committed to a ledger and all that good stuff. Now we say we want to define a new service. So the way we do that is we have to send an authenticated request to create a service definition for the name. And so we'll say, something is a valid instance of test to end-to-end.acidns10.attested.name if the host data is this digest. So that means the confessional container execution policy, which contains the layers of the container, the command it's running, the things it's mounting, the whether it's a privileged container or not, all these aspects of the container, they need to match this exactly. This is probably not how most policies would look like. They would be more detailed than that. Maybe they would rely on endorsements coming from elsewhere, or maybe they would be checking on these certain aspects of the policy. But this is like a very simple one. So it just says like, you get to call your service this, or it gets to be an instance of that if its host data and the attestation is exactly this. And obviously it does need to match the platform policy that we set up earlier, right? So to register our service, the service will come up and it will send a codesign request with its attestation staple to it. The key that's used to sign the request needs to be bound in the attestation. And there's a handshake there, and the ADNS server, verifies things and says, yeah, okay, this is fine. I register this policy for the service under this name, and so yeah. So then from here on, we have the key that was attested is valid TS key for the IP. So if we resolve that name in the future from the ADNS server, we'll be getting that key or that set of keys if we registered one as valid instances of the service. So here we start a little service instance. We point it at our ADNS server. And yeah, we register with it, and then we start serving requests over TLS. So on the client side now, before we resolve anything, we want to bootstrap our trust in ADNS. It's no good resolving TLSA records if we don't know where they come from. If the TLS server that's handing these things over to us is, making them up or is not enforcing policies correctly, they could mean nothing, and maybe we're not talking to real representatives of the services. So we need to do a first round of attestation of the server. And we need to make sure that we're happy with the server we're talking to. It meets our predefined idea of what a valid ADNS is. So here there are two boxes. There's a service definition and platform definition. They're the same idea as for the services, but for the ADNS servers, this is something that needs to be shipped as collateral. So like similar to CA roots with your base images. This is like your shared notion, your shared understanding in your environment of what the valid ADNS is. And so once you've done that, then you can essentially get your signed KSK from ADNS, and then you can know that, with that, using standard DNSSEC mechanisms, you can authenticate all the records that are being served by this ADNS server to you. So that bit is custom at the beginning, but once you've done that and you've just pinned your KSK, you can use standard bind, and you can use a bunch of standard tooling from here on. So that's quite nice. So this is sort of what the sequence looks like, and essentially you're doing the same steps that the ADNS server is doing when it's registering a service connecting to it, but you're doing that to the ADNS server as a client on startup. And once you've done that, you have this this KSK, you can trust. So there's this little demo showing how the script runs. So we get the KSK back. That's just executed the sequence of code that was on the left on the previous slide. So once we've done that, we can bind things. So we can set the KSK in bind. So we can tell bind, hey, from here on, you need to use that to authenticate the records, whatever is served to you for this zone here. So ACI DNS 10.attested.name. This is the zone we use for the demo. And so anything that's under there needs to be signed that way. Yeah, I mean, you can just set the configuration and update bind. That's pretty straightforward. And so once we've done that, then we can just use a client and connect, discover the service IP and the TLS key using DNS, DNSSEC, and DANE. So these are pre-existing standards. So we can just go get the IP, we can go get the TLS key, and that we don't need anything custom for that. Like that's well supported by servers and resolvers out there. Obviously, if you did try to connect to that directly, I would say, oh no, this is a self-signed certificate. This is not endorsed by the normal web PKI, so we can't do anything with that at this point. So when we establish TR sessions, we do need to do that initial bit of getting the TRSA key and configuring OpenSSL to make use of that, and only that to connect. And so unfortunately, there's not really enough configuration you can use to tell OpenSSL to do this. And so we have a small OpenSSL patch that's in the repo that you need to apply. And using that patch, essentially, you can hook up to a call that enables Dane to say, if you want to enable Dane for your client, which is a prerequisite for this, then we will hook up a callback that will go and discover the TSA record for the target every time you try to connect, and get the key from there and then pin that for the connection going forward. So if you apply that patch to the OpenSSL you use, then your client doesn't need changes and can just connect directly and do everything in transparency, which I think is the big gain here. You don't have to roll out big changes or updates, protocols. You can just apply this relatively small patch. That's the smallest we've managed to make it. Obviously, it'd be nicer if you could work with a completely standard OpenSSL, but we've not worked out a way to do that. So here's a demo of you LD preload your patch version. And with that, then you're able to connect and everything works well, and you don't get this rejection error that you got earlier because you're talking to somebody with a self-signed certificate, because now you use Dane to connect to them. So that's kind of the end of the demo. I have some pointers. So the code for the demo is here, is open source, and so people are welcome to go and have a look and kick the tires and try it for themselves. There's a link to the paper. There's various links to the RFCs that this leverages. There's a link to CCF, which is the framework we use to implement the server, but you could implement this any other way you want. So that kind of concludes, I think, the presentations, and maybe we can look at questions now. So I see there's lots of hands raised again. Giri?
Yeah, thank you for the informative presentation. I hopefully this question is quick. Regarding the use of Rego, I saw that the policy at launch was included in the host data. Is there anything else that the platform, whether it be S&P or SGX or CCA, has to act upon regarding policy, or is that all handled between the host and launch and the CVM that's implementing the DNS server?
So the platform claims are exposed. Obviously, yeah, they're different for each platform. So maybe you can go back. I'm sorry, I'm just having some problems with PowerPoint, but the custom details of the attestation in particular are exposed directly to Rego, and so you can write something that looks at all the stuff that's in your SCV SNP attestation. So to give an example, yeah, here you'd have product name and reported TCB and other aspects of that. So your platform policy can capture all these things, however precise you want to be. I think in general, you probably have a list of architectures in mind, maybe a level of patching for the TCB, perhaps some configuration flags. And so that's what's captured and exposed to that policy for you to enforce in the zone.
Okay, so if the attestation report doesn't contain sufficient information to enforce the policy against, then you may go back to the platform vendors and ask them to change their attestation reports. Is that correct?
Yes, that is correct.
Okay.
Yeah,
Got
we
it.
think the current level is not bad, but yeah, more details always welcome. Yeah.
Got it. Okay, thank you.
Mohammed?
Yeah, thanks for the presentation. I have another question, which is on what is your plan for did you talk to some of the PKIs? Are they willing to implement it? Are there any plans from Microsoft on the side of standardization? And what are the kind of next steps that you see? And if you can, PKI interest is there or not, kind of making it more implementable from that perspective. Do you have anything to share on that?
it's being discussed inside Microsoft. I think it's at the point where there are discussions with product teams to decide, whether and how to take this forward. I don't really have an update I can share externally at this point. In terms of standards, it doesn't really need a lot of extra standards because it's using DNSSEC and Dane, which are existing RFCs. So, I mean, the main thing, obviously, that benefit from being standardized is the attestation reports themselves. But that requires hardware changes or requires convergence over time. And I guess if or when that happens, then the policies themselves could be standardized. But it's not entirely clear that they need to be. You could imagine that each zone or each subzone would have its own policy language or mechanism. There's not really a strong benefit to forcing everybody to using the same language to do these things because the zones are naturally sort of owned by different entities. So if you have people in one zone choosing to use Rego and people in another zone, they want to use CEDAR or CL or whatever to do their policy, that seems fine. That's not really a problem. So I don't, there's not like an obvious standardization opportunity there that we can see. But if you see one and you want to tell us about it, that's fine too. Yeah.
Yeah, right. I was thinking maybe I misunderstood something. So what I understood is that there are some changes required in the PKI in order to support attestation. I agree with you completely that Dane and other things are completely standardized, but aren't the PKIs required to actually make a change in order to support attestation? That's currently not being done, even though, let's say, Dane and other things are still a standard. Did I miss something? Are there changes required in the PKIs to be able to verify that? Isn't it the case?
I don't think so. I'm not 100% sure what you mean by PKI. Like in the end, you're basically pushing keys in these DNS records, so there's no real you don't really need elaborate certificates, or you don't need the certificates to be any given way or whatever. You just need to push keys there, and you can store raw keys in DNSSEC. They don't need to be certificates. So I don't think you need PKI changes as such, right? To get this to work, and there weren't any. The only small implementation change that you need for OpenSSL that you may need for various TS libraries that by default they will not default to Dane or pin Dane for certain zones. So if you want to know that you're using that and it's not like silently falling back to the web PKI, for example, you need to tell your library, hey, you need to not fall back, and for this zone that you use, you must use DNSSEC and you must use Dane, right? But that's just kind of an implementation thing. It's not really a standardization thing as far as I can tell.
Right. So you need to do some configuration. That's what I understood. So in the TLS libraries. Okay, perfect. Thanks a lot.
Yeah,
Cool.
exactly.
Cool.
That's
Thanks.
Hey, Fritz. Good to see
Hey,
you.
Maureen. Happy to cross paths again. Nice presentations. Thanks for presenting. I similar to the PKI stuff in the previous question, it makes me wonder what moonshot style things we want to strive for as a community, right? So do we even need PKIs anymore once we move the whole internet to ADNS, have individual keys in the DNS record, and can then kind of just say, look, this is some attestation evidence that is tied to this URL or something. Now, does it help us at all for anything? Because you can, you still don't know what that code does, right? But it at least gives you some maybe TLS equivalent statement, right? Or like some web PKI equivalent statement. That's what I'm thinking.
Yes. So, I mean, you're completely right. In the extreme, if everybody had moved to a system like this, then you don't really need CAs or anything like that.
Yeah.
You have a single hierarchy. That was always the idea behind Dane, right? Like it attested DNS, to be clear, did not invent any of this. This predates this whole effort. This is just trying to leverage conventional computing to this, which we think is important and very good. But the idea behind Dane was to try and unify these hierarchies and have a single hierarchy for all this stuff. So yes, absolutely, that's 100% right. In practice, it doesn't seem to have panned out this way, and Dane, as we know, was not widely rolled out and widely deployed. So maybe the fact that this is attested and that you get much better guarantees is a good way to move things forward. And also, if you can make sure that your tested DNS server is transparent and has a full, auditable ledger of everything it does, then you get the same kind of guarantees or even better than CT, right? Because you not only know all the assurance that's been done for the zone, all the records that have been published and kept, but also the attestations, the hardware attestations that were used to decide whether these things should be published. And so people should be able to go back and audit that, call you out if you've done things that are incorrect or don't match the policies you publish.
But philosophically, you have no guarantee that the attested entity will not leak its key to any to anything else, right? Like you will need to perform some actual verification of that hash to get that guarantee, right?
Yes, 100%. You're operating under standard confidential computing assumption. So if you've looked at the attestation and you've looked at the code and you've reproduced the bill or whatever, you've audited to your satisfaction, then you believe you understand its behavior. If you haven't done that and you've checked the attestation, but you just got a big digest and you don't know the digest of what it is, then your guarantees are.
But so where are you getting that proved or trusted hash now from when everything is under ADNS? Where's the chicken and egg?
So that's a good question, and it's tempting to point people to the paper, but the spoiler is that there's a separate system called CTS, which is a transparency ledger for the code, and that's where we root things, right? So we're saying all the code that's ever used to run services and that's used to run ADNS, should be published there and should be subject to transparency. And there we have actually recently completed some standardization effort. So RFCs 9942, COSI receipts, and 43, the SCID architecture to describe how you can make code transparent and have a good system to expose that. And so we think that is basically your root of trust for that. So it's these ledgers where you publish that code, and you probably depend on the degree of not just witnessing these ledgers, but people reproducing the bills and auditing the code that's published in there, to believe that is correct. So yeah, that's a very good point. And there is this external system where you keep track of the codes and where it needs to be transparent and visible to others.
It's CCF all the way down. Makes sense.
Yeah, which is also a CCF application. Like, we do everything in CCF application, but that's kind of a detail. That's not very interesting in this case.
Thanks.
Yeah.
Hey, I was splitting my attention between the presentation and the chat stream going, so I may have missed some obvious things. Just the DNS client establishing its trust in the DNS server. Is that an attestation that precedes a long-lived TLS connection? And is there a UDP variant of this?
So it's not really the DNS client doing this, but it's conceptually is the client VM or something like that doing that at startup time, or the environment where the client is running. And that's not a long-lived TNS connection. So there's a TLS handshake with the DNS server, and it's fetching the attestation over that, sort of like the same way a lot of services work today, right? So it's you attest after you connect, and then you check the key, you check the attestation of the remote, and if you're happy with that, you sort of pin the key signing key that you get from there, and you say from here on, this is what I'm going to trust. This is a bit simplified for the POC. There obviously that does need to expire, and you will need to redo this from time to time. But the timeline for that is usually quite long-lived compared to all your individual connections you're going to do to services. So, but no, there's not a long-lived needs to stay up TLS connection from the client to the DNS server.
Okay, I see. So it gets the TLS certificate. Got it. All right, and then have you thought about a UDP variant of this that would be similarly secure?
A UDP variant of the handshake, you mean?
Right. Well, I guess.
But no, but like you could do it over Quick or something if you wanted, right? And then I guess that would. You do need to authenticate your ADNS server on the other side, right?
Yeah, I guess I was thinking of UDP queries, but I guess never mind.
Yeah, you could do a custom protocol, but like, yeah, I mean TLS works pretty well for that. It's not cheap, but we think this is something you do very infrequently when you set up your clients, and then you sort of pin the Kscape for a long time. So, yeah, just TLS basically. Yeah.
Okay, thanks.
So very, very quick question. So is it possible for the DNS server to relate over to somebody else and fake that all thing?
Is it possible for the DNS server to fake the attestation? You mean?
Yes.
It's no more possible than for any other TE, right? Is that? I'm not.
So
I'm not sure. I'm missing something.
like the trust that you place in DNS today will be the same. There is no additional trust introduced into it. Is this kind of a good summary of that?
No. You trust it much more. Today
you
you trust DNS only to find locations. Here you discover locations and TLS keys, right? So you really need to check its attestation, and you need to convince yourself that the DNS server is trustworthy. If you don't do that, then you have a problem, right? You're delegating trust. You're delegating attestation verification for the services you're going to connect to in the future to the DNS server. So you do need to be careful when you bootstrap your trust in that.
Mm-hmm. Okay, very interesting. Thanks.
Okay, great. Any other questions? I guess we're more or less on time.
Yeah, looks like we're at the top of the hour.
Okay, thank you very much.
Yeah, thank you. I see that the link is in the agenda on Google Docs, so appreciate it.
Thanks, Omri. Have a great couple weeks, everybody.
Thank you. Goodbye.
Thanks, Amori. Bye-bye.